Get ready to have your mind blown because the Large Hadron Collider has just unveiled yet another shocking discovery that has left scientists reeling with excitement, but mostly with fear. Just like in 2012, the LHC confirmed the existence of the Higgs boson, a particle theorized for over 50 years, revolutionizing particle physics. Join us as we embark on a journey to unravel the mystery behind this new terrifying revelation. The Large Hadron Collider, aka LHC, is the mighty atom smasher that has been captivating the world with its mind-boggling discoveries and sheer awesomeness. The world before the Large Hadron Collider was a time of uncertainty, unanswered questions, of theories without experimental confirmation. It was a time when the most fundamental aspects of our universe remained shrouded in suspense, and scientists could only speculate about what lay beyond the limits of their understanding. The laws of physics as we know them were incomplete, leaving us with a fragmented view of the universe that we called home. But with the creation of the LHC, everything changed. The veil of uncertainty was lifted, and a new era of discovery and understanding began. The world would never be the same again. LHC is the ultimate playground for scientists, where they get to smash subatomic particles together at unimaginable speeds and energies, all in the name of advancing our understanding of the universe. Don't worry, they actually get the work done too. First off, let's talk about the sheer size of this thing. The LHC is a circular tunnel that's 27 kilometers, 17 miles, in circumference, buried beneath the Swiss-French border. That's about the length of 6,750 Olympic swimming pools laid end to end. And don't even get started on the amount of energy it takes to run this behemoth. The LHC consumes enough electricity to power a small city, which is why it has its own dedicated power station. And you thought your electric bill was bad. But what really makes the LHC so fascinating is what it's capable of doing. It's basically a giant particle accelerator, which means it can smash subatomic particles to incredibly high speeds and energies and then smash them into each other. When these particles collide, they release a burst of energy that can create new particles and reveal the fundamental building blocks of the universe. This is where the thrill of scientific discovery meets the spine-tingling excitement of exploring the unknown, a place where our deepest fears and our insatiable curiosity collide. Now we know what you're thinking. This all sounds very serious and academic. Where's the fun in that? Well, fear not, because the LHC has plenty of geeky references to keep you at the edge of your seat. For starters, the LHC has a particle accelerator called the Atlas detector. If you're a fan of Greek mythology, you'll know that Atlas was the titan who held up the sky on his shoulders. And what does the Atlas detector do? It helps us understand the fundamental structure of the universe, just like Atlas held up the fundamental structure of the world. Clever, right? And if you're a fan of the TV show The Big Bang Theory, you'll remember that Sheldon, Leonard, Howard, and Raj were all super excited about the LHC. In fact, they even went to visit it in Switzerland. Of course, their visit didn't quite go as planned, but that's a story for another time. The LHC has already made some incredible discoveries that haunt the scientists in their dreams. A tiny particle that holds the key to the universe. It sounds like something straight out of a sci-fi movie, but it's actually a reality. The Higgs boson, also called the God particle, is one of the most elusive and fascinating particles in the universe, and it has captured the imagination of scientists and the public alike. It's not just a fancy name, it's a particle that could help us unlock the mysteries of the universe. If you have watched the time-traveling Marmalade Dark, you might recognize its name. In the show, the Higgs boson is used as a catalyst for time travel, allowing characters to travel through different eras and alternate universes. It's a fascinating concept that ties in with the real-life implications of the Higgs boson and its role in shaping the universe. But unlike in the show, the Higgs boson isn't a magic ticket to time travel in real life, or at least not yet. It's a complex particle that requires some of the most advanced technology and research methods in the world to observe. It's a particle that's been theorized for decades, but it wasn't until the LHC came along that we were able to observe it directly. So what exactly is the Higgs boson and why is it so important? Well, to answer that question we need to go back to the very beginning of the universe, where we find ourselves in a hot, dense, and infinitely small point called a singularity. As the universe expanded and cooled due to the Big Bang, particles started to appear and the fundamental forces of nature emerged. It's like the ultimate cosmic party where the tiniest building blocks of the universe showed up in their finest attires. But there was a problem. They needed a field to hold the pearl necklace of our universe. Imagine a universe where everything is weightless and just floats around like a feather in the wind. Sounds pretty surreal, right? Well, that's exactly what our universe would be like if it wasn't for the Higgs field. In order for particles to have mass, they need to interact with the Higgs field, which permeates all of space. Without the Higgs field, particles would be massless and the universe as we know it would be very different, because it wouldn't be, unified. Enter the Higgs boson, the particle that's associated with the Higgs field. Think of the Higgs boson as the key to the universe's weight problem, giving all other particles the mass they need. But the importance of the Higgs boson goes beyond just being a building block of the universe. Without the Higgs field, matter as we know it would not exist. In this universe, there would be no stable atoms or molecules, no chemistry and no biology. The fabric of reality would be completely different, and we would not be here to observe it. It's like the star quarterback on a football team. It's essential for the team's success, but it also has a lot of pressure on it to perform. All fundamental particles would be doomed to an eternal race at the merciless speed of light, forever fleeting and never able to slow down or come to rest. The discovery of the Higgs boson was a major breakthrough in particle physics, and it earned Peter Higgs and François Englert the Nobel Prize in Physics in 2013. But that's not all. In the vastness of the universe, the fundamental forces that shape our world remain a mystery as well. In the world we know, four known forces reign supreme: gravity, electromagnetism, the strong nuclear force and the weak nuclear force. Yet the cosmos whispers of a fifth force that lies hidden, waiting to be discovered. Some say this fifth force is linked to the existence of extra dimensions as well. But where could we find the key to unlocking these secrets? The answer lies in the Higgs boson, the beacon of hope, the light at the end of the tunnel. But with great power comes great risk, and some fear that the LHC may unleash a catastrophic event that could spell doom for us all. The hunt for the Higgs boson has been a long and arduous journey, filled with countless obstacles and setbacks. Researchers had to consider a variety of options when trying to determine the mass of the particle, as the standard model provided no guidance. To make matters worse, the Higgs boson decays into other particles almost immediately after it's created, making it nearly impossible to capture. Theorists predicted that there would be a variety of possible decay paths for the particle, adding to the complexity of the hunt. But despite the challenges, scientists pressed on, driven by a desire to understand the fundamental nature of the universe. The LHC was built, and researchers risked everything to collide protons together in a bid to find the elusive particle. As the search intensified, so did the fears of those who questioned the consequences of playing God. The Large Hadron Collider, the very same device that helps us understand the universe we live in, could be the cause of our ultimate destruction. For instance, some people believe that the LHC is actually a secret portal to the underworld, capable of unleashing demons and other terrifying creatures into our world. Others claim that the LHC is actually a powerful weapon, capable of destroying the entire planet with just the flip of a switch. And let's not forget about those who think that the LHC is a government plot to control our minds and turn us all into mindless zombies. There are also some who believe that the LHC is up to some seriously sinister stuff. They claim that the particle collisions at the LHC are actually part of a secret government experiment to create a new world order, one where only the elite would be allowed to survive. This apocalyptic theory revolves around the idea of a false vacuum, a theoretical state of space where the energy is not at its lowest possible level. If the LHC were to create a false vacuum, it could trigger a series of catastrophic events that would ultimately lead to the end of everything we know and love. This doomsday scenario may seem like a far-fetched idea, but it is a real concern for some experts. The LHC experiments could potentially create the conditions necessary for a false vacuum to form, leading to the creation of black holes that could swallow entire galaxies. The risks associated with a false vacuum are so profound that they could change everything we know about the universe. It's like Thanos' snap in the Marvel Cinematic Universe, but instead of half the universe disappearing, the entire universe could collapse into nothingness. Although the creation of black holes in the LHC is considered unlikely, the potential consequences of a false vacuum are so grave they cannot be ignored. Now you may be wondering, why hasn't it happened yet? It turns out that the Higgs field, which plays a crucial role in the concept of false vacuum, would have to overcome an enormous energy barrier through a process called quantum tunneling to get to the lower energy true vacuum state. This barrier is so huge that it would likely take many times the age of the universe for the transition to occur. In other words, although the collapse of the universe is a problem in theory, practically, it's nothing to worry about, for now. The Higgs field is metastable, temporarily stuck in a false vacuum space, which means that although the risk of a doomsday scenario is real, it's not an immediate concern. Now let us move on to another literally dark topic at the hand of LHC scientists who are constantly baffled by this cosmic conundrum. The universe is endless and mysterious, and its composition is not what it seems. What we see, the stars, the galaxy and the planets, only make up a fraction of what's out there. In fact, the matter we know and understand, that which makes up everything we see, touch, and feel, is just 5% of the universe's content. What about the other 95%? It's made up of a mysterious substance called dark matter. Dark matter is like a ghost, a shadow, an unseen force that dominates the universe. It's impossible to detect because it doesn't interact with electromagnetic force, which means it doesn't absorb, reflect, or emit light. However, it exerts a powerful gravitational force on the visible matter, holding galaxies together and controlling their movements. The frightening truth is that dark matter outweighs visible matter by roughly 6 to 1, making up 27% of the universe. It's like a silent predator lurking in the shadows, waiting to strike. But what is dark matter made of? One theory suggests that it could contain supersymmetric particles, hypothesized particles that are partners to those already known in the Standard Model. These particles are difficult to detect, but experiments at the Large Hadron Collider may provide clues about their existence. Many theories suggest that dark matter particles could be produced at the LHC, escaping through the detectors unnoticed. It's like a horror movie where the monster is invisible, but you can sense its presence through the chaos it creates. The stakes are high and the dangers are real. As the LHC smashes particles together at breakneck speeds, there is a very real possibility that dark matter particles could be unleashed into our world, causing destruction on an unimaginable scale. The mere thought of these invisible ghostly particles wreaking havoc in our world is enough to send shivers down the spine. Yet despite the risks, the quest for knowledge drives these fearless scientists forward. The thrill of discovery and the possibility of unraveling the mysteries of the universe are too great to ignore. With the fate of the universe hanging in the balance, they push on, determined to unlock the secrets of dark matter and unravel the very fabric of the cosmos. But beyond all of this, the scientific community is abuzz with excitement as news of the latest discovery from the Large Hadron Collider spreads like wildfire. The launch of particle beams at unprecedented levels of energy, the world's largest and most powerful accelerator, has unlocked the secrets of the universe once again. The world of particle physics has been turned on its head as a brand new type of pentaquark, composed of 5 quarks, has been revealed. But that's not all. A new type of tetraquark made up of 4 quarks has also been discovered. And if these discoveries weren't enough, the first ever pair of tetraquarks has been detected, uncovering a world of subatomic particles previously thought to be unimaginable. LHC scientists are packing more quarks than the Avengers have superheroes. This latest breakthrough marks the first time a pentaquark with a strange quark has been found, a feat that was thought to be impossible just a few years ago. The sheer magnitude of this discovery is staggering. With a statistical significance of 15 standard deviations, this is a discovery that defies the laws of chance and confirms the existence of this long-sought-after particle with absolute certainty. It's also a testament to the ingenuity and tenacity of the brilliant scientists and engineers at the Large Hadron Collider. The discovery of these new particles is not just a remarkable feat of science, but it also has terrifying implications for our understanding of the universe. The fact that there are still so many unknown particles and states of matter out there raises the question of what else is lurking in the depths of space. What if there are even more exotic particles that we have yet to discover? Particles that could wreak havoc on our very existence. Could these particles have the potential to destabilize the very fabric of space-time or pose a threat to our planet?